Cheong. He's head of product and marketing from Trina Solar Asia Pacific. Lim is handling product and marketing in APAC at Trina Solar. He joined the Trina in November 2011 and has been responsible for product management, training, and the promotion of new products to APAC customers. He has over 9 years of PV industry experience and is supporting a broad base of customers in different segments on product and technical matters. He's going to deliver how to further reduce PV LCOE with largest module technology. Hi, Lim. Are you able to share a screen now and start your presentation? Thank you.
Yes, thank you, Jessica. So let me share my screen. Okay, so I think everyone can see my screen now.
Yes.
Thanks again to EnergyBox for organizing the webinar today, and thank you to all the participants. I'm Lim from Trina Solar, so I will take this chance to run through Trina Solar as a company and also how our latest products can help to reduce LCOE for the solar projects in Israel. So just a brief background of Trina Solar. So we are founded in 1997. We have over 20 years of experience in PV module manufacturing, and in 2014 we are world's largest PV module supplier with the world's most number of global shipment worldwide. And one of the key milestones was last year 2020, where we were listed again on the Shanghai Star Market, and we have also launched our 600 watt plus ultra high power modules, setting the industry to move into the PV 6.0 era. So in terms of globalization, myself, I'm based in Singapore, so it's our Asia Pacific HQ. So from there, we are supporting the ASEAN market, Australia, up to Korea, India, and also the Israel market. So till date, we have shipped more than 70 gigawatt of modules worldwide, and we have over 100 plus customers on a global basis with 15,000 employees. So as my colleague Andrew mentioned earlier, we have been ranked the top most bankable module supplier for 6 years, from 2016 to 2021. In terms of our achievement in APAC, over the last 3 years, we have shipped almost 9 gigawatt of modules, and is definitely one of the top 3 module supplier for the Asia Pacific region. In terms of leading technology, so starting from the left, we have launched our 210 Vertex ultra high power modules. So this is using currently the industry largest wafer size, 210 and then the center is our N-type iTopCon. So we have also started mass production for some of the N-type models. The average efficiency are up to 24% for the cell. And on the right will be our advanced HJT technology. So this is currently in the planning, and it might be available sometime in 2022. So just a brief recap on how the module power has evolved over the last 10 years. So you can see, especially over the last 2 years since 2020 onwards, the industry has been very exciting. We see great increase in the power bin of between 50 watt, 100 watt, all the way. Now we are looking at almost 700 watt of modules if we use the N-type cell. So when we first floated the idea of 600 watt, this model, there was only about 30 plus partners that have been in this alliance. But fast forward now, 1 year, 1.5 years down the road, now we have about 89 companies that is part of this 600 watt plus alliance. So you can see in terms of the upstream, wafer, cell, down all the way to the downstream, the BoS, the systems, we have all the supply chain is already in place to support the 600 watt era. So this is our Vertex family. So from here you can see there's a total of 5 series. Starting from the left side, this is our Vertex S, which is targeted for the resi market. And then we have the 18, 19, 20. So this can be used for the commercial industrial rooftops. And then we also have the 21 series, which mainly is used for the large ground-mounted projects. So our power bins cover from 400 watt all the way to 670 watt. So in terms of our technology that we have put into our modules, so starting from the top left corner, you will see this is the largest wafer size, 210 now in the market. And to match with this larger surface area, we have also increased our number of bus bar from the previous 9 bus bar to 12 bus bar for our half cut 210 mm modules. So at the same time as the cell become bigger, we have also upgraded our non-destructing cutting method. So this is basically to use a low temperature laser to slice through the cell so that we can have a very smooth cell edge. And at the same time, we're able to maintain similar mechanical loading properties as compared to a non-cut cell. Then on the bottom right, be our high density interconnection technology. So essentially, this is to minimize the gap between each cell so that we can shift the few mm of the overall dimension of the cell, and then this will improve our module efficiency by about 0.2, 0.3%. So just a bit more specifics onto our DE20 series, which is our 600 watt. So you can see all the features has been put into this module, as mentioned earlier, in terms of the 210 mm multi-bus bar, non-destructive cutting, high density interconnection, and this is a 6x10 layout half-cut cell available in both the backsheet monofacial and also the glass bifacial. So this is based on a low voltage, high current design, where we have a VOC of about 41.3 volts as compared to the 182, which will be probably in the high 40s, about 48, 49. So we did a simple case study to compare about a 1 megawatt rooftop system across the different module power, 545, 182, and then we have the 595, 210, and the 655, 210. So this is based on using a 100 kilowatt inverter. So you can see here, because of our low voltage design, we're actually able to have less strings per inverter, and our string power is also very much increased as compared to the 182. So in terms of the specific, you can see as we use a higher power bin, our total number of modules used will be less, and this will translate to cost savings for our customers. At the same time, because of our low VOC, that we can see there's more modules that can be connected per string. The overall number of strings is actually reduced. Then this will cascade down to the other effects, where we'll be using less connectors, shorter DC cables, and also less mode. So in this particular case study, we have made some assumptions and input some of the numbers. So you can see here, compared to the 182, we are actually able to have some cost savings in the overall BOS coming from the different parameters here. So next, this will be our highest power bin module. This is our 21 series, highest power bin up to 670 watt. So you can see here, similarly, we have also input all our previous technology, all our technology mentioned earlier to this module. So it's high power, high reliability, and then of course, also based on a similar low voltage design concept. So we also have a higher string power as compared to 182. So we have worked together with a third-party agency, Frankfurt, to run a simulation for 2 different scenarios, one in Germany and one in Spain. So for the Germany, we are using the fixed tube and for monofacial, and for Spain is the bifacial one portrait tracker. So you can see here, the G12 is referring to our 210 mm. So when we use a G12 665 watt as compared to an M10, which is a 182 540 watt, in terms of the capex wise, definitely we are seeing significant savings. And overall in the LCOE sector, we can also see in this particular case study for the fixed tube is about -4.1% lower as compared to the 182, and for the one portrait tracker is about 1.9% lower. So this is the details of comparison and the study. So you can see the cost savings coming from the module, the inverter, the civil engineering, electrical system, mounting and installation. So this is mainly coming from because of the higher power bin. So we are able to reduce the number of modules used. At the same time, this will flow down to higher string power, less DC cables, less structures, less installation work, less labor costs. And so this will definitely help our customers to lower the initial investment. So We launched the ultra high power modules. So there's a lot of questions in the market about how reliable is this module. So we have also put together to show our reliability assurance of Trina ultra high power Vertex module. So in terms of, at the bottom will be, of course, our state of the art, world recognized production and quality assurance system. Then we also have our own state key lab that is doing product design testing. And on top of that, we have verified our products through the different kind of tests in terms of the mechanical reliability, the delivery solution, and also the electrical reliability. So in terms of product optimization design, so basically you can see this is a comparison when we see our 670 watt is about 4.6% longer than the 18272 cell, but it's 3.4% shorter when they're using a 78 cell design. In terms of width wise, about 15% wider. So we have put the module through all the standard tests in terms of the static load, and we have also considered the larger dimension of the module. So we have optimized our frame design in terms of the thickness, the chamber shaft, and everything, so that we are able to maintain the same mechanical loading properties as compared to the conventional module. So we have put our modules through the 5 enhanced tests beside the standard static load, which is the non-uniform snow load, static load at extreme road temperature, hill impact, enhanced dynamic load test, and also a wind tunnel test. So from here, we can see that for the standard static load test, this is definitely meeting the IEC requirements, which is the 5,400 front and 2,400 Pascal back. So this is for both the fixed tube and also for the tracker is about 2,400 plus minus, depending on the design. And we have also put our modules through the hill impact test. So you can see we have tested up to 35 mm. So this is a short video of showing how the test is being done. So you can see the hill is shoot onto the module. And the glass itself, there's no damage. And then when we test the power degradation after the test, is also very minimal power degradation. Similarly, there's also the enhanced dynamic load test. So this is a plus minus 1,000 Pascal. So we have put our modules through about 20,000 cycles. So you can see even after the 20,000 cycles, the power degradation is only about 0.1%. And we have also tried on the extreme wind tunnel test. So you can see here, the wind load is applied from 30 meters per second to about 62 meters per second, each lasting for about 30 seconds. So the whole test is maintained and stabilized for about 900 seconds. So over here, we can see that up to 59.54 meters per second, there's no significant damage. But beyond that, we do see some damage in terms of the frame on the module itself. Then at the EL test, you can see at 3 meters, there's no damage before and after the EL image. So how can we transport these larger dimension modules? So you can see on the left, this is our standard two-stack horizontal packing. So on the right is our innovative vertical packing method. So this is applicable for our DE20, DE21, DEG21C.0.20. So this is how it will look like inside a 40-foot container. So you can see, although our number of pallets might be less compared to the 182, but in terms of the total power per container, actually we are about 12% higher as compared to the 182. So this is also to show some examples and reference project that we have already supplied our ultra high power modules. So this is a 112 megawatt tracker project in Shanghai. So this is what it looks like at the installation site itself. And on the right, you can see we have a stand supporter, which will help the modules to be secured at site and before transporting to the actual installation tracker position. So this is also another project that we have tested out in Japan. So this is about 1 megawatt project, bifacial double glass. So you can see in terms of the handling, it is all proper with the stand supporter, and also can transport as per normal using the forklift at the site. This is another example in Korea. So this is a 600 watt DE20 bifacial series. So you can see it's a ground mounted fixed tilt project, and the carton box and pallets are placed just beside the structures. So in terms of compatibility wise, we have also worked with various inverters company. So as mentioned earlier, Trina Vertex ultra high power modules are low voltage, high current design. So we need to select the inverter models which is compatible with the high current. So you can see we have worked with almost 21 mainstream inverter suppliers, and there are over 200 models that has been checked and compatible with Trina modules. So below are some of the case study and projects that's already been installed. And in terms of tracker wise, as my colleague Andrew has mentioned earlier, we have a Trina tracker, both the 1 portrait and 2 portrait tracker is already compatible. So at the same time, there's also other brands in the market that are also compatible with the Trina Vertex module. So we also have a design tool assistant. If you're interested, you can also visit the website just to take a look at the different trackers and inverters that's available there. And so it will be able to provide some assistance and advice on whether which inverters or which tracker are compatible with the models that you select. So lastly, these are all the reference projects that we have for our Vertex series. So about more than 10 gigawatts has already been shipped. And now we are looking at about 25 gigawatt of site orders and waiting for fulfillment. Okay, so that I've come to the end of my presentation. Thank you.
Thank you so much, Lim.